Welcome viewers. This morning we want to solve the Olympiad math question on the board. This is a right angle triangle. We have here x raised to the power 2 and the x cubed. Let's find the value of x. Solution. Now, because it is a right angle triangle, we will approach the question using Pythagoras method. Okay, Pythagoras theorem, which says that the hypotenuse side squared, which is x cubed raised to the power 2, is equal to the opposite squared, then plus the adjacent squared. Okay, good. What I did, I squared x cubed equal to, which is the hypotenuse side, equal to x squared also squared, and then x squared, that is adjacent square plus opposite square, equal to hypotenuse squared. Now, by law of exponents, exponential law, I will multiply the powers to have it as x raised to the power 6 is equal to x raised to the power 4, then plus x raised to the power 2. Let me divide all through by x raised to the power 2. And that means I will have x raised to the power 6 all over x raised to the power 2 is equal to x raised to the power 4 all over x raised to the power 2 plus x raised to the power 2 all over x raised to the power 2. And by this division, going by law of indices, division in indices, this is now going to give me x raised to the power 4 equal to x raised to the power 2 then plus 1. I can move what I have by the right hand side to the left, and this is going to give me x raised to the power 4 minus x squared minus 1 equal to 0. Alright, let me express x raised to the power 4 as x raised to the power 2 all raised to the power 2, then minus x raised to the power 2 minus 1 equal to 0. At this point, I can say let x raised to the power 2 be equal to n. And this means anywhere I see x raised to the power 2, I will replace it with a letter n. And that is going to form for me n raised to the power 2 here minus n minus 1 equal to 0. It is now a typical quadratic equation. So I can go by any of the methods of quadratic equation. And to this, let's go by quadratic formula. In quadratic formula, I'll have it that n1, n2 should be equal to minus b plus or minus the square root of b squared minus 4ac. Everything divided by 2a. Okay? And by this, the value of a from the equation is equal to 1, and the value of b is equal to minus 1, and the value of c is equal to minus 1 as well. I can now substitute. So by substitution, I'll have minus 1 plus or minus the square root of b, which is minus 1 squared, minus 4 multiplied by a, which is 1, multiplied by c, minus 1. Everything divided by 2 multiplied by a, which is 1. Okay, minus will give me 1 plus or minus the square root of minus 1 squared will give me 1, minus multiplied by this minus 1 will give me plus. Therefore, 4 times 1 will give me 4. Everything divided by 2 times 1, which is 2. Okay, moving forward, I am going to have, from here, I will have 1 plus or minus the square root of 5 all over 2. Okay, and this is the value of n. We can now say that n1 is equal to 1 minus square root of 5 all over 2. But this will give us negative. Therefore, we will reject this. Okay, rejected. Okay, also n2 is going to give me 1 plus the square root of 5 all over 2. So we are going to work with this. And working with this, it therefore implies, because from here we said let x raised to the power 2 equal to n. We are looking for x here, not actually n. And we can now say, recall that x squared is equal to n. So I will replace this n2, which is the one we are going to work, the positive value, real value, will now be equal to x squared equal to 1 plus the square root of 5 all over 2. And this means to clear this square, I will take square root on both sides, and by the left, if I take square root of the x squared, I will get x equal to plus or minus the square root of 1 plus square root of 5 all over 2. Okay, but then if I have x equal to minus square root of 1 plus root 5 all over 2, we cannot have that. So this also should be rejected. And we work with the positive value of x, where we have x equal to plus then the square root of 1 plus root 5 all over 2. But note that 1 plus root 5 all over 2 is equal to, always represented as 5, and it is called the golden ratio. Okay? In conclusion, we can now say that the value of x is equal to exactly this, but we can also evaluate it and get our answer in decimal. That means I will now find the square root of 5 plus 1, then divided by 2 is going to give me a plus square root of 1.618, meaning that the final value of x is going to be square root of 1.618, which is equal to plus 1.272, the final value of x. Thank you, dear friends, for watching to the end. Please do subscribe to my channel, Tutor Cletus Okoli. God bless you.